Welcome back to Talk Tensors. Learners, this was for you.
Oh, yeah.
We're diving deep into U2A, Unified Unimodal Adaptation for Robust and Efficient Multimodal Learning.
Okay.
And this paper, it's really interesting because it's all about AI and how it handles missing information.
Right.
You know, it's like when you're watching a video and the audio cuts out.
Yeah, or like an image won't load or something like that.
Tracks.
Humans, we kind of fill in the gaps.
We could figure it out, right?
Yeah, we can usually figure it out, but AI...
But AI traditionally struggles with this.
It really struggles. So that's why this paper is really cool, because it's proposing this solution. It's called U2A.
Okay.
And it basically makes AI more resilient.
Okay, so it's like giving AI a dose of common sense.
Exactly.
Helping it deal with the unexpected.
Yeah.
So let's break down what makes U2A so special.
All right.
The paper explains that it adapts unimodal encoders. These are models that are trained on a single data type.
Right.
Like just images or just text to work together in multimodal scenarios. So what's the big deal about this approach?
You imagine you have a team of like specialized chefs.
Okay.
One's like a pasta chef.
Okay.
One's a sushi chef.
Okay.
And one's a taco chef.
Okay.
They're like the best at their single cuisine.
Right.
But what if you need them to like collaborate on some
kind of
crazy fusion dish?
Fusion,
U2A is like giving them just a few extra tools and tips.
Got it.
To work together seamlessly.
Instead
without having to completely retrain from scratch.
So instead of starting from zero, they're building on this expertise they already have.
Right.
That makes it much more efficient.
Exactly. Yeah.
Now, the paper mentions something called LoRa. As kind of a key part of this adaptation process. Can you unpack that for us?
LoRa is it stands for low rank adaptation.
Okay.
And it's like giving those chefs a crash course in each other's techniques. Just the essential bits they need.
So they don't have to become experts.
Yeah, they don't have to fully become masters at each other's cuisine.
Right.
They just get like
a
few tips.
Yeah, the basics.
Yeah.
So instead of forcing them to master everything, LoRa provides just a small set of additional parameters.
Okay.
And that allows the models to kind of adapt their existing knowledge.
So it keeps things lightweight and fast.
Exactly.
Okay.
Which is really important when you're dealing with these.
Yeah, when you're dealing with AI.
Yeah, these huge.
This complex AI models.
Yes, exactly.
So that's really clever.
Yeah.
It's all about maximizing efficiency without
compromising performance?
Yeah, compromising performance.
Yeah. Now, the paper also dives into these things called mask tokens.
Yes.
Which are used to handle missing information.
Right.
How do those work exactly?
Okay, so think of it like this.
Okay.
You're trying to understand a story that your friend's telling you.
Okay.
But they keep leaving out key details.
Right.
Mask tokens are like placeholder words that you kind of mentally insert to make sense of the story.
Okay, so in U2A,
when a modality like audio is missing, these tokens stand in.
Right.
And the model learns to predict the missing information.
Based on the available data.
Yes.
So like the visuals.
Yes, exactly.
So it's like U2A is playing a game of fill in the blanks.
Yeah, exactly.
Yeah, and using those context clues to complete the picture.
Exactly.
Now, to understand the significance of this of this research, let's kind of rewind a bit.
All right.
Can you give us a rundown of the history that led to this point? What were some of the major milestones in multimodal learning that kind of paved the way for U2A?
So the journey of multimodal learning has been really interesting. Initially, the focus was on unimodal tasks. So training models to excel in one specific domain.
Right.
Like image recognition. Or natural language processing. However, the real world, it rarely presents information in these like isolated chunks.
Right. It's a sensory symphony out there.
It is.
It's everything all at once.
Right.
So when did researchers start tackling this multimodal challenge?
The shift towards multimodal learning really gained momentum. In the early 2010s. With some like pioneering works. Exploring tasks like image captioning. So using text to describe images. And visual question answering. So providing textual answers based on images. these early attempts often relied on these simple techniques like concatenating features from different modalities.
I can imagine that approach had its limitations.
Definitely.
It's like trying to understand a movie by just like reading the script and looking at a few stills. You're
missing so much.
Yeah, the interplay between the visuals, the audio, and the dialogue. It's all part of it.
Exactly.
Researchers
quickly realized that to truly capture the richness of multimodal data,
they needed more sophisticated.
They needed something more sophisticated.
Yeah.
So this led to the development of novel architectures, like attention mechanisms, which allow models to kind of selectively focus on relevant information.
So it's like our brains filtering out.
Exactly. It's just like
distractions and zeroing in.
Yeah, it's like how our brains work.
On what's important.
Yep.
So were those the breakthroughs? So those were
paved the way.
Yeah, they were significant steps.
For U2A, for sure. But the challenge of missing modalities remained this hurdle.
Yeah. Yeah.
Yeah, so early multimodal models, they were often pretty brittle. And their performance would just plummet.
If one piece of the puzzle...
one piece was missing.
Yeah.
Yeah.
It sounds like they were missing that human-like ability.
Yeah, they were missing that.
To adapt and improvise.
Yeah.
So how did the research community start addressing this robustness problem?
A couple of different approaches emerged.
Okay.
Some people focused on developing these like specialized training procedures.
Okay.
So like teaching models to handle missing data by like artificially masking out portions of the input during training. Others explored techniques to like impute or fill in missing information using statistical methods.
Okay.
So
it seems like they were trying to give AI crutches.
Yeah, they were trying
to navigate this world.
Give them some help.
That's built for humans.
Yeah.
With all our senses intact.
Right. Yeah, that's a great way to put it.
So while these techniques...
And while those showed
some promise.
Yeah, some promise.
They often added... complexity, computational overhead.
Yeah.
Or required specific domain knowledge.
Right.
So it sounds like U2A's beauty.
So yeah, the beauty of U2A lies in its simplicity
and efficiency. It leverages what we already have.
That's exactly.
Those powerful unimodal encoders.
Yes.
And adapts them cleverly.
And adapts them in this clever way.
Yeah, for the messy reality.
Yeah, for the real world.
Of multimodal data.
Right.
Now, the paper also reveals this fascinating concept of modality dependence.
Right.
This idea that different types of data rely on certain modalities more heavily.
Or than others.
Yeah, can you elaborate on that?
Sure.
What are the implications?
So it's like realizing that a cookbook relies heavily on text and images.
Right.
But a musical performance hinges on audio.
Right.
So U2A's evaluations showed that this dependence varies across different categories.
Okay.
For instance, when classifying movie genres, textual information played a big role in identifying biography films.
Okay.
But visuals dominated action films.
So it's not just about AI understanding different modalities, but also recognizing.
Yeah, but recognizing which ones
matter most. In a given context.
Exactly.
That opens up some exciting possibilities.
It does.
Doesn't it?
Yeah.
So.
Now, before we wrap up, let's move on to our novel notions segment.
Yes.
Where we take these research findings and we brainstorm potential extensions. Pushing the boundaries of what's possible.
Cool.
Ready to get those creative juices flowing.
I am. Awesome. Yeah. So, all right. So for our first novel notion. What if we took this concept of adapting these pre-trained models and applied it to the challenge of building AI assistants? That can like really understand and respond to human emotions.
That's a fascinating idea. Imagine an AI assistant that can not only process your words, but also interpret your tone of voice, your facial expressions, even physiological signals.
Oh, wow.
Like your heart rate.
Yeah.
By adapting models that are trained on these individual modalities, like speech recognition.
Facial emotion analysis. Biosignal processing.
Right.
We could create an assistant
Yeah.
that grasps.
That can actually understand.
Yeah, the full spectrum.
Yeah.
Of human emotion.
It's like giving AI.
It is. It's like giving it
emotional intelligence.
Emotional intelligence.
Yeah.
So it could
it could
tailor its responses based on
your state.
Your current state.
Yeah.
Instead of just a generic, I'm sorry to hear that.
Right.
It could offer
a
comforting message.
Yeah, when you're feeling down, or celebrate with you when you're happy.
Exactly.
Yeah. But the challenge there, I think, would be ensuring that the AI is responding empathetically and ethically.
We don't want an AI.
Yeah, we don't want an AI that's
exploiting
people or
or manipulating,
right?
Yeah.
Yeah, so
that's a crucial point.
A really important consideration.
We need to ensure that AI, emotional intelligence, is used responsibly and ethically. Always prioritizing human well-being.
Human well-being first.
Now, for our second novel notion.
Right.
Let's shift gears a little bit.
Okay.
And think about the future of healthcare.
Okay.
Could U2A's approach be used to develop personalized treatment plans that adapt to a patient's unique needs?
That's a great idea.
And responses.
I love that.
Imagine a world where medical AI analyzes not only your medical records and test results, but also real-time data.
Wow.
From wearable sensors.
Okay.
Lifestyle patterns.
Yeah.
Even genetic information.
That's amazing.
By adapting models trained on all these different sources, we could create a dynamic treatment plan.
So it's constantly adjusting.
Adjusting and learning based on
how you're doing.
Yeah, your individual progress.
Yeah, your progress.
And feedback.
And your feedback.
It's like having an AI doctor.
It's like having
that's constantly learning.
Yeah, an AI doctor.
And refining your treatment approach.
That's with you.
Yeah, ensuring you receive
all the time
the most effective care possible.
Yeah, that's incredible.
It could even predict.
Imagine if
potential complications or adverse reactions
before they even happen. Wow.
This level of personalized medicine
that would be amazing.
Could revolutionize healthcare.
It would.
Leading to more precise diagnoses, better treatment outcomes.
Yeah. Ultimately.
And healthier lives.
Yeah. Of course.
Kind of privacy.
You have to.
And security would be paramount.
Think about that.
In such a system.
Yeah, for sure.
We need to ensure that patients have complete control over their data. And that it's used responsibly and ethically. Well, these novel notions.
Those are some.
Certainly spark
really cool ideas.
Our imaginations.
Yeah.
As we wrap up this deep dive into U2A, what's the key takeaway you want our listeners to remember?
The biggest thing to take away is that we're seeing this paradigm shift in AI.
Okay.
Instead of training these specialized models for every single task, we're moving towards this future where AI can adapt,
learn, and evolve.
Like humans do.
Just like we do.
U2A's success in handling these missing modalities.
Yeah.
It's a testament.
It's a really
to this progress.
Right sign.
It's like we're giving AI the tools to navigate.
The tools to navigate.
The real world.
Unpredictable reality.
Yeah, the messy world.
That we all live in.
We live in.
And that opens up.
It does.
So many possibilities.
A ton of
possibilities,
By embracing adaptability.
And efficiency. We can unlock.
We can really.
AI's true potential.
Not just to automate tasks.
Not just to automate.
To really
augment human capabilities. And create a better world.
It really does.
Yeah, and it opens up a ton of possibilities. For the future.
Yeah, for sure.
Don't forget, folks.
Oh, yeah.
You can find a link to the full U2A paper.
Yes.
In the show notes. We encourage you.
Please.
To explore the technical detail.
And dive in.
And see what
you think.
Sparks your own novel notions.
Yeah, what are your novel notions?
Thanks for joining us.
Thanks for having me.
On this deep dive into U2A.
It's been fun.
We'll catch you next time.
See ya.
On Talk Tensors.
Bye.
Where we continue to explore
the
ever-evolving world.
It's always changing.
Of machine learning.
That's right.